All right. So in our bonding chapter, we were still talking about both ionic and covalent. So we're going to start with ionic to have that one up top, and then we'll have the covalent stuff on the bottom. So let's go ahead and label this ionic. Okay, so a couple things about ionic. We're dealing with an electron transfer as opposed to on our covalent stuff, it's electron sharing, right? So this is where an electron was actually moving from one thing to the other, okay? And more specifically, it was moving from a cation to the anion, okay? Electron transfer from my cation to the anion. Your cations are the positive ones, your anions are the negative ones. Usually your cation tends to be a metal. Remember, that was the way we kind of recognize our ionic stuff. Your anions tend to be your nonmetal. So if you're ever asked about, hey, which one is the anion, which one is the negative charge, which one is going to accept, then you had to know where on your periodic table your metals and nonmetals were. So just draw yourself a little reminder that you're looking for that stair-step line on your periodic table. And to the right of it is all of your nonmetals. And to the left of it are all your metals. Okay. And just so you guys know, if I am going too fast, you're more than welcome to take a picture to copy it down, because I'd rather you get something from this, okay? All right. The next thing that was important about our ionic stuff is that we know no prefixes. So when I ask you to name something, do not say monodi, tetrapenta, all those, okay? No prefixes in the name. That is only for covalent stuff. Then we had to make sure we knew how to come up with our formulas by crisscross charges. And those charges are your oxidation numbers, right? Your oxidation numbers, which on that resource page right next to you is down here in the bottom right. Okay, that resource page right next to you, that's where you're going to find it. The reason we had to make sure that we could come up with that formula was so that we knew how to draw the electron transfer. Okay, so for example, if we had the example of something that had potassium and oxygen, how does the electron transfer go? When you're asked to draw that, okay, the first thing you're going to do is write your formula. So we're going to figure out potassium is K, oxygen is O. I'm going to look at my little reference page down in the bottom right. I'm going to get their oxidation number. So potassium had a +1, oxygen had a -2. Once I get those, I'm going to take those two values and I'm going to crisscross them to come up with my final formula. That final formula is K2O, meaning I'm going to have to draw 2 potassiums and 1 oxygen. When you're asked to name it, just in case, you would have named it the metal and then your non-metal ending in "ide." So we wouldn't say oxygen, we would say oxide. And remember, if you say oxygenide, that's okay, because I will know that you were attempting to end in IDE, which is a big deal. So that's step 1 when you're asked to show the transfer. Step 2 is you draw their Lewis structures, right? Their Lewis dot structures. Or dot diagram. I'll just write that. So what you're going to do for your dot diagram is that we have 2 potassiums that we have to draw. So you're going to draw 2 Ks. And then we have 1 oxygen. So I'm going to draw 1 O. You need to find their valence electrons. Okay? This is not the same thing as their oxidation charges. Okay? Their valence electrons, remember, on your periodic table are indicated with the A's. Right? So, potassium is in group 1. That's 1A. So we're going to, basically this is in 1A. So we can have 1 dot on each of my potassiums. 1 dot on each of my potassiums. I put a 1A to just remind myself that's what I'm looking at. This one is in 6A or 16, right? So that means you need 6 dots. 1, 2, 3, 4, 5, and 6. Once you've drawn who you have individually, remember the whole point of an ionic electron transfer idea is that you're showing it with arrows. So if you think about what we've been doing, what we've been practicing with our covalent stuff, you were just connecting the single dots, right? On ionic, you're still paying attention to the single dots, but you're connecting them with an arrow. So you're going to show from the metal to the non-metal, that's what direction it goes. Your arrow is going to point to from single dot to single dot, just like that. Once you have the arrows drawn, you're on your last step, and that is brackets and charges, right? So the after picture. So after pick. All right, so you're going to use brackets to show that potassium did turn into a cation with a +1 charge. So you have to draw both of them. Then you'll show oxygen turned into something with that -2 charge, but you do have to show, so you have to forget, or not forget this, don't forget this, that you have to show that it now has 8 electrons around it. It gained 2 of those electrons. So it has that -2 charge. And that would be your final answer, and that would be it. Okay, so once again, make your formula, draw out the right amounts of every element, write their little valence electron dot diagrams, arrows from single dot to single dot, brackets with the charges. And remember, these charges, I didn't just pull them out of nowhere, okay? You're still following this idea, those oxidation numbers that are there, okay? All right. So our quick little cheat sheet for covalent stuff. Let's go ahead and put covalent down here at the bottom. So for covalent, we're going to have nonmetal with a nonmetal. And instead of an electron transfer, this is going to be electron sharing. Electron sharing. Okay, so connecting your single dots. This is also the one where prefixes in the name. It's an easy way to recognize them. Okay, your prefixes, just to be clear, are on that reference page as well. They're listed right there on that reference page, top right. There's a little list of them, okay? All right. So the only thing that we're going to do for this one is we're going to remind ourselves how to draw a Lewis structure. That's the drawings for these, right? So I'll just pull one from one of the examples that we had just done. We'll do nitrogen with 3 hydrogens. So the way that we would name this with the prefixes and everything is we would have, usually we would say mononitrogen trihydride, but there is one weird rule about covalent, and that is that you never write mono on the first one. You can't write the mono on the first one. Okay? You would have just put nitrogen trihydride. If there was 2 nitrogens, you would leave it dihydrogen trihydride. Mono is just the only one. You can't write on the first one. All right, so when it comes to drawing them, you would draw their dot diagram. So again, you're looking at what column they are on the periodic table. And you're looking at the tops. This one is in group 15, which has a 5A on it, right? So that means we're going to go 5 valence electrons. So 1, 2, 3, 4, 5. Then you know that you have hydrogens, which are all 1. So you can just kind of spread those out. And once you have those all drawn, you could just connect single dot to single dot. Okay? And once you kind of have a general idea of what gets connected, then you can kind of pretend like you're pulling on a string and everything kind of tightens up, right? So I don't know if you guys have ever seen those dolls. Anywho, so nitrogen with a lone pair on top, and then it's connected to hydrogens. Okay, and that's your Lewis structure. Remember, you can have double and triple bonds. So if you want to have one more example, you can also leave carbon on here. 1, 2, 3, 4. Let's say we were putting it with another carbon. And then 2 hydrogens and 2 chlorines. So I would have to make sure my chlorines have 7 around them. And then you would just kind of start connecting single dots like we were doing earlier, right? And then you would notice that you have all these other single dots. You would just connect them and notice that you have a double bond. Now, this is a totally made up little molecule right here, so don't totally quote me on this part. Just showing you an example. Oops. I guess I shouldn't mess up my example. There we go. So this would just be an example of a double bond thing, which some of you guys got to see that yesterday or the day before. Okay. So that's going to be your cheat sheet, and then you have the little half page glued in on the next side, right? So there, you open your journal up and you have both of those right there. And that should hopefully help a bit, okay? So hopefully you got to write that down. If not, you can definitely come over, snap a picture, and copy it in. But what we're going to do is I am going to hand you